All right, so let's take a look at problems 6 through 9. And this problem is asking us to find part A, f minus g of x, part B, f times g of x, and part C, f divided by g of x. And then we'll talk about, what is the domain of each operation. So for part A, right, quite simply, we're just subtracting these two functions. So f minus g of x, right, this means f of x minus g of x. Okay, so you could just plug in the two functions and then subtract them. My only suggestion is that you make sure you put parentheses around your quantity, okay? And then you can simplify as much as you can here. So if I combine some like terms, I'm going to end up with minus 2x minus 8. Okay, so there's the operation of f of x minus g of x. Okay, and then part B, we're asked to multiply. So f times g of x, right? Again, the other notation is just f of x times g of x like this. You can FOIL this if you like, x squared minus x minus 6 times x plus 2. I'm not going to actually FOIL it because out of the interest of time, I guess. But again, you would just distribute 3 times and then combine like terms. Okay, so I'm just going to leave it like this for now. And then last but not least, we're asked to find out what f divided by g of x is. Okay, so again, the alternative notation is just this, f of x over g of x. Let me erase that. F of x divided by g of x. Okay, so my f of x is x squared minus x minus 6, and my g of x is x plus 2. Okay, if you want to factor this, you can, right? It's x minus 3 times x plus 2, and actually ends up canceling out. But for convenience sake, I'm not going to simplify this any further. Okay? I'm just going to leave it like this. Okay, so what I want to really emphasize here is the domain of each operation. Okay, so the way I go and figure out the domain, if you look at your notes, on page 1, the domain of H is the domain of both f and g. And so what that means is you need to find the domain of f and g separately. And then step number 3 was to find the overlap, right? So let's figure out what the domain of f is. So over here, my f of x, domain of f. What is the domain of f? So over here, right, this is a polynomial, right? More specifically, it's a quadratic. And the domain of a polynomial function is just all real, right? There's not much work you need to do. So I'm just going to say all real. And the domain of g, this is a linear function, okay? And in general, linear functions, the domains are all real. Okay, so now that I have the domain of f and g, I can go back and take a look at each domain of each operation. Okay, so what is the domain of f of x minus g of x? The overlap of f and g, right? The domain of f and g for this operation, f of x minus g of x, the overlap of all real and all real is just all real. Okay? So that's the domain of f of x minus g of x. Same thing, when you're doing the domain of f of x times g of x, the domain is found by finding the domain of f, finding the domain of g, which we already did, right? And they're both all real, so the combination or the overlap of all real is just all real. All right, but when you get to part C, the domain of f is still all real, domain of g is all real, right? But you have to remember, this is the one where it's the quotient, right? The quotient has to include values such that g of x does not equal 0, right? This is my g of x function. So what I'm going to do is simply solve and plug in g of x. In other words, x cannot equal negative 2, right? And this kind of matches what you know already. So the overlap of all real, and the fact that g of x cannot equal to 0, well, this domain only has just to be all x cannot equal negative 2. Okay. And that's really how you find the domain of functions when you combine them arithmetically. The one that you really have to be worried about is part C, is when you divide. And the only thing you need to do for that is set g of x not equal to 0, solve for x. Essentially, you've done this before. Okay. All right, so if that example did not quite make much sense, let's do another one, number 7. And there's a reason why I give you a lot of examples, so you can get the hang of it, hopefully, by the 3rd or 4th example. Okay, so again, I'm going to kind of just breeze through parts A, B, C, parts A through C, right? Part A asks us to find what f of x minus g of x is, and I'm not even going to bother, simplifying or whatnot. I'm just going to leave it like this. So, Mrs. Zhu, on a quiz or test, would you ask us to simplify? It depends, right? I mean, the whole point of this lesson really is that you know that you can combine two functions and form another function. Maybe I'm not necessarily asking you for the algebra skills per se. The important part is actually the domain, okay? And that's more the difficult part, if you will. Okay, so part B, right, asks us to find fx times g of x. And quite simply, I'm just going to write these, I'm going to write the product of x squared minus 9 times x squared, right, all over x squared plus 4. Okay, so don't try to do anything fancy and multiply the x squared into the x squared minus 9. Just leave it outside. Okay, you can even put parentheses over here if you want. And then part C, f of x divided by g of x. This one might require a little bit more of an explanation. Okay, so f over g of x, right, is f of x over g of x. My f of x is the square root of x squared minus 9. And my g of x is this, x squared over x squared plus 4. Okay, so, this is a complex fraction, right? You can multiply top and bottom by x squared plus 4. I'm going to do that. And your final result is just going to be this, x squared minus 9. Don't try to multiply inside the radical, just leave it outside, over x squared. Okay, so this one, the algebra might be a little bit tricky. If you don't want to use the LCD method, right, you could say, the square root of x squared minus 9 divided by x squared over x squared plus 4, which means times the reciprocal, right? When you multiply by fractions, you'll get the same result. I mean, alternatively, this is way 2, this is way 1 when you divide a complex fraction. Okay, you'll get the same exact result. Okay, so again, I went through A and B really quickly. I didn't even simplify, right? I just wrote f of x minus g of x, f of x times g of x, and then last but not least, f of x divided by g of x. All right, so what I want to kind of emphasize is the domain, okay? So always follow this procedure. Find the domain of f separately, okay? Domain of f. Now my f right here is the square root of x squared minus 9. Okay, the square root of x squared minus 9 is what f of x is, right? And so if you remember, right, this is an even root function. So the way you solve an even root function, the way you find the domain, is you set the argument greater than or equal to 0. So after that, right, you recognize that this is a quadratic inequality, okay? And the way you solve a quadratic inequality is either sketching or testing on the number line, okay? So I'm going to briefly get the x-intercepts in a quadratic inequality. X is equal to -3, x is equal to +3, right? And you could test on the number line. But you know what? That takes way too much time. I'm just going to sketch this. This is a parabola. And at -3, right, this is +3. And again, just a quick review, right? This means what are the x values such that y is greater than or equal to 0, right? So notice this is plus, 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 plus. Y is greater than or equal to 0 from -infinity to -3, union mark 3 to infinity, okay? That's where the y is positive. So final answer for domain of f, right, is -infinity to -3, union mark 3 to infinity. If you want to write it like this, that's fine. X is less than x is less than or equal to negative 3, I should say. This should actually be a bracket, right? If you want to write x is less than or equal to negative 3 or x is greater than or equal to 3, that works as well, okay? All right, so that's the domain of f. What is the domain? What is the domain of g? Now, what was my g function? My g function was x squared over x squared plus 4. So the way you find the domain of this guy right here, right, is recognize it's a rational function. And you set the denominator not equal to 0. X squared cannot equal to negative 4. If you take the square root of both sides, you're going to get plus or minus 2i. Okay, so you basically exclude the imaginary, right? But we don't care about imaginary. So after we follow these steps, in fact, the domain of g is just going to be all real. Okay, domain of g is all real because we don't care about imaginary. Yes, we exclude plus or minus 2i, but we don't care about that. Okay, so we did all the work. The domain of f is this. X is less than or equal to negative 3 or x is greater than or equal to 3. And the domain of g is all real because we don't care about imaginary. And now if you go back and find the domain of each of these operations separately, right? The overlap of all real and x is less than or equal to negative 3 or x is greater than or equal to 3, right, is just going to be simply domain of this part A, right, when I do f of x minus g of x, is minus infinity to negative 3, bracket, union mark, 3 to infinity. Okay, so again, you could use x is less than or equal to negative 3 or x is greater than or equal to 3 because I didn't specify to use interval notation. So whichever notation you want to use. Same thing on this one, right? This is a multiplication problem. Domain of f times g is the domain of f and the domain of g where they overlap, and you're going to get the same result for this domain. Okay, 3 to infinity, negative infinity to negative 3, union mark 3 to infinity, inclusive. Now, the very last one, right, the domain of f over g, we have to include one extra step. For this one, the extra step is we have to figure out where g of x can't equal to 0, right? Because we cannot divide by 0. Can't divide by 0, right? And that makes sense intuitively, right? So our g of x is this. And remember when I said don't cross multiply when you solve a rational inequality? Well, this is not a rational inequality. This one you're just solving for x, right? So if you cross multiply here, that's okay. And you're going to quite simply just get x can't equal to 0. Okay, so let's put all this together. The overlap of the domain of f, right, of my original function is negative 3 to 3, or sorry, minus infinity to negative 3, 3 to infinity. And that's, so this is domain of f. Domain of g is all real, right? That's g. Sorry, I'm running out of space here. This is g. And then this is where g of x can't equal to 0. So let me erase this. This is g of x can't equal to 0. Okay. This is where g of x can't equal to 0. So the overlap of all three, right, is right here, right? This would be the overlap of all three. So in fact, when you say that g of x can't equal to 0, right, notice 0 is not even part of the overlap. So your final answer for this domain is still going to be minus infinity to negative 3, bracket, union mark, 3 to infinity. Okay, so that's still going to be your final answer because even though 0 is not part of the domain, it's not part of this overlap right here. Okay, so again, if you're a visual learner, I would try to graph it on the number line if you're having trouble seeing where the overlap is. Okay, let's do one more together, and then maybe number 9, maybe just pause the video and see if you can get it on your own. Okay, so number 8, f of x is equal to 8x. G of x is equal to 2x to the 5 over 6. So again, really quickly, right, what is f minus g of x? Well, it's going to be simply x minus 2x to the 5 over 6. Okay, not much simplifying that you can do. I would just leave it like that. What is f times g of x? If you want, right, you could simplify this a little bit further. 8 times 2 is 16. Properties of exponents, x to the first times x to the 5 over 6, right? This is 6 over 6 plus 5 over 6. You're going to get, okay, over 6 plus 5 over 6. If I add the exponents using properties of exponents, you're going to get this, okay, 16x to the 11 over 6. And then part C, f of x divided by g of x. Okay, I'm going to use this notation. You're going to have 8x over 2x to the 5 over 6. You could leave it like this. My 6 looks really bad here. It's like it's going to fall off the denominator. A little bit better, right? You could leave it like this, or if you really wanted to, you could simplify. This would be 4x to the 1 minus 5 over 6, which is equal to 4x to the 1 6. Okay, so this is okay. If you didn't quite simplify it, that's okay as well. Okay, so again, the actual operations, you can see them going through pretty quickly, because that's really not the important thing. I don't think that's the part that you guys are going to be struggling with. It's probably the part where it's asking you to find the domain. Okay, so I'm going to slow down here on the domain part. The domain of part A, B, and C is what we're asked to find for part D. Okay, so again, how do I do this? Find a domain of f separately, domain of f. So you look at f, right? It's right here. That's a linear function. You know that's all real. Now be careful when you find the domain of g. This is an even root, right? So if I were to actually rewrite this, this is 2 to the 6th root of x, right? 2 to the 6th root of x, you know, to the power of 5, right? And the way you find the domain of an even root is you set the argument, okay, greater than or equal to 0. You're going to simply get x is greater than or equal to 0. And I know this is actually called a polynomial inequality, right? But your only x-intercept is 0. And you will find that x is just going to be greater than or equal to 0. Okay, so when you solve this. In fact, you can even rewrite this such that you write it like this. 2 to the 6th root of x to the 5th, right? In that case, you don't even have to worry about x to the 5. You could just say x is greater than or equal to 0. Okay, so that's the domain of an even root. You set the argument greater than or equal to 0, and you solve for x. So that is the domain of this. And then you can actually go back to part A, B, and C now. Okay, so for part A, the domain of f minus g of x, right, is just the overlap of f and g. The overlap of all real x is greater than or equal to 0 is just x is greater than or equal to 0. The domain of f times g of x is the overlap of f and g, and just x is greater than or equal to 0. All right, so part C with the slow down, right, we have to do this one extra step where g of x does not equal to 0. So what was my g of x function here? Okay, it was 2x to the 5 over 6. It can't equal to 0. Let's get x by itself. If you were to get x by itself, divide both sides by 2. 0 divided by 2 is 0. And then if you take the 6/5 of both sides, right, just showing you all the work, if you take the 6/5 root of both sides, you're still going to get x can't equal to 0, okay? So the way you figure out part C, right, is you combine all real, you combine x is greater than or equal to 0, and you combine x can't equal to 0, right? So if you combine all of this guy, and this guy for part C, the final answer is just going to be x is greater than 0, okay? So notice on this example, I didn't quite use interval notation. I'm going back and forth between inequality notation and interval notation. That's not the point of emphasis. I just want you to understand, how do you find the domain? Basically, you find the domain of f, find the domain of g separately, see where they overlap, and then for part C, you have to include one extra step, which is the fact that g of x cannot equal to 0, and then overlap that with the domain of f and g that you found in the beginning. Okay, so why don't you guys try number 9 on your own? I will give you the solution, but I would suggest that you pause the video, okay, and see if you get the right answer. So why don't you try this, click pause, and then see if you get the correct answer when I go over it. All right, so again, hopefully that was enough time as you click pause. So let me again just go through the actual operations. X over x plus 5 minus x to the 4th. I'm not even going to worry about combining those two. I'm just going to leave it like that. Part B, I'm asked to multiply. So when you multiply x times x to the 4th over x plus 5, you could write it like this, x to the 5th, right, using properties of exponents. And then last but not least, part C, what is f over g? This one I'll show you a little bit more work. Okay, so again, f of x is x over x plus 5 divided by g of x. Again, try not to get confused by the complex fraction, right? The LCD of top and bottom is just x plus 5. So I'm going to multiply top and bottom by x plus 5. And this is my result. Okay, this is the actual operation for each part, A through C. Okay, so let's go and find the domain of each operation. So part D, the domain of f. Okay, notice I have a rational function in part f, right? So the way I find the domain is set the denominator not equal to 0. You're going to get all x cannot equal to -5. The domain of g, this is a polynomial function. The domain of a polynomial is typically all real. Okay? Remember, the only functions you have to worry about are rational functions and even root. Okay? Later on, we'll have to worry about domain of trig functions, but we're in chapter 1. We don't have to worry about that now. Okay, so for part A, right, it's the overlap of f and g. The overlap of all real and x can't equal -5 is just all x can't equal to -5. Part B, the domain of f times g. Domain of this is also all x can't equal -5. Okay, domain. And last but not least, right, for part C, I have to do one extra step, and that extra step is g of x can't equal to 0. So x to the 4th can't equal to 0 if you take the 4th root of both sides. Oops, that's a terrible parentheses, but hopefully you realize what I'm trying to do here. X can't equal to 0. 0 to the 1/4 is just 0. Okay, so if I combine all x can't equal -5, all real, all x can't equal to 0, right? You would say the domain of this is all x can't equal to 0. All x can't equal to -5. Okay, and if you were to write this in interval notation on this last one, I would plot this on the number line, okay, just to help you visualize. Right, this is all x can't equal to -5, and all x can't equal to 0. So minus infinity to -5, union mark, -5 to 0, union mark 0 to infinity.